Okay, welcome to area under the normal curve. So what that means is this is stuff. As we said, it was a 100% or the probability of 1. Okay? That means anything that can happen would happen in this normal curve. So that means when we all this area, as I said before, what is this? All this area right here, it's this, there we go. There's, percentage underneath here. 100% is all this, it's filled in. Okay, so what we want to know now is how much is there, depending on the standard deviation that we're at and the mean. So what we use, fantastically, is the calculator. Okay, use the calculator. We are going to use second vars 2. So go ahead and hit that in your calculator now, second vars 2, and you should see something called normal CDF. Okay, and you have 4 things that you have to fill in. The lower bound, the upper bound, the mean, and the standard deviation. So we're going to get to it, but sometimes if you have to go forever, so that means if you have this normal curve, and you want to see how many people score higher than you, so you want to know what percent or how many people score above your score or whatever you've got, you may want to know that goes into infinity. So we can't put infinity on there. So what we have to do is have to put a really high or a really low number, depending on if it's a lower or an upper bound. Okay? Just have to make sure it's more than 5 standard deviations above or below the mean. I don't necessarily do a calculation. I generally just pick a really big number like 10,000 and go with it. Okay, so for example, what's the lower bound, upper bound, mean, and standard deviation? So when we have 0 as the mean, it is understood that this is the z-score. So when we're talking z-score, the mean is always 0 and the standard deviation is always 1. So then the lower bound here is the lower spot that you have to get, the lowest that you'll go, and the higher bound is here. Now we just type that into our calculator, and I wanted the probability to the nearest 10,000th and the 10th of a percent for a percent. Oh. Forget the nearest, to the nearest 10th, do the 1 in parentheses, even though, whatever. 8186. Okay, and the percent, we just take that basically and multiply it by 100. 81.9%. So the area between those two would be 81.9. So this is basically what we did when we were doing the regular normal curve with basic standard deviation, sometimes halves. But now we're doing standard deviations like negative 1.86. So it's not a really fantastic one for the 68% and the 95% that we know and love. So what we do is the calculator kind of gives these us. So the lower bound here is negative 1.86. The upper bound, well, 5 standard deviations above the mean would be 5, but let's just go crazy and put 100. It doesn't matter as long as it's really big. Okay, so we put those number in. So it's second vars 2, and we plug these in, and we get a probability of 0.9686 and a percent of 96.9%. Okay, now we have the situation where there's 2 of them. We want to know the probability or the percent area under the curve that is above this score and below that score. Okay, so in this case, we're going to call this number 1 and this number 2. So we do it twice. So we have to do 2 normal CDFs and then we add them together. Okay, that's it. So we'll get this area here, this area here, and add them up. So why don't you see if you can do the normal CDF for number 1 for this spot and the normal CDF for 2, and we'll come back and see how we do. Okay, this is what I got for the two of them. Yes, I got this decimal for number 1. I got this decimal for number 2. Remember, do not round until you've added them together. I know it seems a little bit annoying to type those numbers in, but that's better than getting the question wrong. So take the full numbers here and add them together, and you get some like 0.2819508782, and then we can round and do the multiplying. So 2820 for the probability and 28.2 for the percent. Okay, moving on. So that's when we have, that's when we have z-scores. Okay, this just is an example of your normal curve. You're going to have to set this up on your own for the most part. Just kind of be able to draw the little basic stuff. You don't need these things. So what you need to do is you put the mean where it's supposed to go, the standard deviation, and then you're going to find the percent area under the curve. So the mean is 500. Okay, so that always goes in the middle. You guys are good at this now, so shouldn't be a problem. The mean is 500. The standard deviation is 100. So each one of these, so this would be 600, this is 700, this is 800, and down 400, 300, 200. Now this one's pretty easy. Between 400 and 700, you could actually, if you remember your percentages, just add those up in your head. The calculator, however, will do it for you. You just have to put the correct lower bound, upper bound, mean, and standard deviation. Okay, so the lower bound would be 400, the upper bound would be 700, the mean is 500, and the standard deviation is 100. And it will just tell you that it's 81.9%. Okay, I rounded and I did all the fun stuff. What is the probability to the nearest 10,000? So this time they're asking for probability and not percent. So we're not multiplying by anything. We want it below 349. So our mean again is 500. Our standard deviation is 100. So below 349, this is 400. So it's something like this. I like to draw it out, just a basic draw, so I could determine my lower bound and upper bound. Sometimes it's a little confusing to write those and just figure those out. Okay, so again, my lower bound, see my mean here is 500, so my lower bound has to be really low. So I'm just going to make it 10,000. 1,000 might not be enough, but it is still 5 standard deviations below the mean. Actually, negative 1,000 might be enough, but I like to go big. Go big or go home, that's what I say. So the upper bound is then 349. The mean is still 500. And the standard deviation is still 100. Just do your normal CDF and figure out that's your probability. It's 0.065521737. That's what I got. Okay, and then they want to know less than 349 or greater than 700. So it's basically that number that I just got up there. Less than 349 is this way. I just need to figure out greater than 700. 700 would be right around here. Okay, so again, we have to have, this will be my number 1, and this will be my number 2. So number 1, I just did, and I found out that it's 0.065521737. Okay, again, you don't want to round. Even though we did round in the top one, you don't want to round until the very end. So I really just have to do number 2. Sorry, that was funny. Lower 700, upper bound. Again, if I'm going to infinity here, I'm just going to make it 10,000 because it's fun. Mu is, that's the mean, and the standard deviation is 100. So again, put those in your normal CDF, and you should get 0.022750062. Add these two together, 0.0882717,987. And we want it to the nearest 10,000, so that's right there. So it's 0.0883. All right, have a wonderful day.